a new unique text in statistics with full of stories and jokes. Let me tell you a little bit about it. You will never regret reading of this new text in statistics which is full of stories and jokes. There are a lot of jokes and stories which you may or may not have heard in your daily life, and supported with an application of statistics. All stories and jokes are also supported with appropriate pictures, which give fun feeling to the readers. Some stories or jokes are very close to real-world problems in our daily life and in science. We regret that these stories or jokes are not based on any real person. A few lectures are also available on a DVD at the back of the book. First time in the world where elephants go to college and speak statistically. Until today, elephants were seen only going to schools. Jokes and stories are designed to make students creative in real life. Read or listen the preface of the text. Speaking statistically, elephants go to college. By Sarjinder Singh and Stephen A. Settery, Department of Mathematics, Texas A&M University Kingsville, Texas, USA. For detail, drop an email, sarjinder@yahoo.com. In this lecture, we shall review basics of statistics. For example, definition of statistics, meaning of a population in statistics, meaning of a sample in statistics, why samples should be random and representative, why we do sampling. Define statistics. Think of defining statistics. Today everybody defines statistics in their own way. Medical doctors, engineers, sociologists, psychologists, agricultural scientists, economists, business management, space scientists and so on, define statistics as per their own needs and thinking. Statisticians define statistics in a way that suits to all sciences. It is a science to describe or predict the behavior of a population based on the random and representative sample taken from the same population. Let me read it again. It is a science to describe or predict the behavior of a population based on the random and representative sample taken from the same population. A few natural questions come to mind. What is a population? What is a sample? What do random and representative mean? Let me define population. The population is a large body of data values to the interest of an investigator. For example, 1. All people living on Earth. 2. All students at Texas A&M University Kingsville. 3. All machines in a factory. 4. All rocks on a hill. 5. All elephants in a zoo. 6. All trees in a forest. 7. All rats in a house. What can be our interest in these populations? In the population 1, we may be interested in estimating the average body temperature of all people living on Earth. In the population 2, we may be interested in estimating the average GPA of all students at Texas A&M University Kingsville. In the population 3, we may be interested in estimating the average life of all machines in the factory. In the population 4, we may be interested in estimating the average age of rocks on a hill. In the population 5, we may be interested in estimating the average diet of all elephants in the zoo. In the population 6, we may be interested in estimating the average wood per tree in the forest. In the population 7, we may be interested in estimating the average wastage by all rats in a house. Note that in statistics, the population does not necessarily consist of only human beings. It is a collection of data values, which may come from human beings, machines, animals, rocks or trees, etc. To understand the meaning of population, let us consider an example. Suppose we have a 2-liter carton of milk. We want to make a cup of tea for a patient. Note that we have only 2-liter milk, thus, the 2-liter milk is our population. The doctor recommends the patient should not drink milk if its fat content is more than 2%. Now, let's say that we wish to know the fat content of the milk before serving for the patient. To find the fat content of the milk, we have to add acid to it. Now if we consider the situation of adding acid to the entire 2 liters of milk, obviously, we can determine the fat content of the entire population of milk by adding acid to the milk. However, the entire population will be destroyed after adding acid to it and we will be unable to make a cup of tea. What should we do? The wise step is to place 1 milliliter of milk in a test tube, add acid to it, and note the fat content. Whatever fat content we read from the 1 milliliter of milk, we can assume is also the true fat content of the entire milk population. The natural question arises, what is 1 milliliter of milk? The obvious answer is that 1 milliliter of milk is called a sample. Thus we can define the sample as follows. The sample is a set of measurements selected from the population of interest. For example, from the first population, select a few healthy people from Earth and note their body temperatures. From the second population, select a few students from the university and note their GPAs. From the third population, select a few machines from the factory and note their ages. From the fourth population, select a few rocks from the hill and find their ages. From the fifth population, select a few elephants from the zoo and note their daily diets. From the sixth population, select a few trees from the forest and weigh their wood. From the seventh population, select a few rats from the house and watch their daily wastage. Let us go back to our example of the 2 liters of milk. Suppose the milk has been in the pot for 5 to 6 hours and that all the fat content is saturated near the upper layer of the milk. If we took a sample of 1 milliliter of milk from the same place where the fat content is saturated, then naturally our sample will show the higher reading of fat. This means we are overestimating the real fat content of the entire milk. Similarly, if we took a sample of 1 milliliter of milk from the bottom of the pot, where the water content is saturated, then the sample will show less fat than the actual fat of the entire milk. This means we are underestimating the real fat content of the entire milk. What should we do now? It is better to stir the milk before taking the sample. Obviously, when we stir the milk before taking the sample, it will become a random and representative sample. Every drop or content of the entire milk will have a chance of selection in the sample. Now, let us define the random sample and a representative sample as follows. 1. Random sample. The sample is said to be random if each element in the population has some chance of selection in a sample. 2. Representative sample. The sample is said to be representative if it contains all kinds of elements or contents of the population under study. However, the random sample may not guarantee a representative sample. For example, while estimating the average income of all persons living in a village, the sample must include all types of people. For example, rich, poor and moderate income level people. If we selected the random sample of only rich people, then we would not be representing the village population. In actual practice, we cannot stir a population. For example, we cannot stir all elephants in a zoo. The elephants will be much too heavy to put in a box and stir them. Please do not do it, because the elephants may die. There are two methods to ensure a random and representative sample. 1. Lottery method. 2. Random numbers table method. These two methods will be discussed later in one of the following lectures, but not in this lecture. In this lecture, let me introduce to you two symbols. 1. Population size. The population size is generally denoted by an uppercase English letter, N. For example, if there are only 6 elephants in a zoo, then we say uppercase letter N is equal to 6. 2. Sample size. The sample size is generally denoted by a lowercase English letter, n. Say that the owner of the circus wishes to ship all the elephants from one zoo to another zoo. It is a cumbersome and expensive job to weigh all the elephants in the zoo, so the owner decides to weigh only 2 elephants. Then, we say, lowercase letter n is equal to 2. Let me tell you a well-known story of a German doctor to understand why we do sampling. In 1861, German doctor Karl Reinhold August Wunderlich took a sample of 25,000 healthy people and found their average body temperature was 98.6 degrees Fahrenheit. Now, when we go to see a doctor, the doctor always checks our temperature and compares it with the standardized value of 98.6 degrees Fahrenheit. Note that this standard result is based on only 25,000 people selected around the world during the 19th century and is still considered valid. Assume, in a new study, the research scientist admitted 100 healthy people in a hospital for 2 days and noted their hourly temperatures. Assume the new study shows that the average body temperature is 98.3 Fahrenheit. What questions come to mind? 1. Which result is more accurate, new study or doctor's results? 2. How did the German doctor select 25,000 healthy people? 3. What is the accuracy of the estimate 98.6 degrees Fahrenheit? 4. What was the quality of thermometer used by the German doctor? Thus, there is no end of such questions coming to our minds. Our question still remains unanswered. Why we do sampling? There are major 4 benefits of sampling. 1. Cost is less. For example, instead of destroying 2-liter milk, we have to destroy only 1 milliliter of milk. 2. Efforts are less. For example, to destroy 1 milliliter milk, we need less efforts. 3. Time consumed is less. It takes less time to destroy 1 milliliter milk than 2-liter milk. 4. Accuracy of measurements is more. It is always easy to take a few accurate observations than too many observations. Doctor took 25,000 observations. New study took only 4,800 observations. Now you think yourself, who is more accurate, new study or doctor? As said earlier, all people define statistics as per their needs and understanding. Now we shall like to define statistics as follows. Statistics is a field of study that has an application in almost every facet of our daily life. We appreciate your listening skills. Hope you enjoyed it. Now you have a nice break. See you in the next lecture.